All right, so we're going to continue to talk about hyperbolas today, and we're going to move away from them being centered at the origin and talk about what do you do if they're not centered at 0, 0. So similar to when we did this with ellipses, we started with ellipses centered at 0, 0, and then we went to ones that had a different center. So that's all that we're going to change today. Everything that we do is still the same, like how you find your a squared, your b squared, your c squared, all of those things that we talked about yesterday with hyperbolas centered at the origin. All of that is the same, except that your center has now changed. So you'll have something that looks like these equations here, where you'll have, like on the top, you'll have x minus h, y minus k. So this again looks a lot like it did when we had ellipses. So this is just showing us that the center is no longer 0, 0. And when you pull the center, remember we always pull the opposite sign than we see. So when it says minus, that means that they really were putting positive numbers in there. So we want to make sure that we pull out the positive number. Again, the same rules apply where you want to look for the bigger number on the bottom of the fractions first, because that's going to be your a squared term. And the other one's going to be your b squared. To find your c squared, you're still going to add a and b because our focus points are still going to be beyond the vertices because we're still dealing with these hyperbolas. And everything else looks the same. You just have to be careful with your vertices and your covertices and foci that you add the correct number to the center. So again, you want to make sure that you identify a squared first so that you can decide, am I using the left or the right side of my chart here? So again, if you guys still have that formula sheet, this would be another good thing to put on there. That should be on the very last, probably last page of that formula sheet, because this is the last section that we're covering for this chapter. So you just want to make sure that you have these two on there as well so that you know which chart you need to use when you're dealing with hyperbolas that are not centered at 0, 0. So I'm going to go through this first one here with you guys. So we have y plus 2 squared over 16 minus x minus 3 squared over 25 equals 1. So I start by looking at my bottom numbers 16 and 25. 25 is bigger, so that means 25 is the a squared term. And so that means that my b squared is 16. So a is going to be positive negative 5, and b is going to be positive negative 4. To find c squared, we need to add a squared and b squared, so add 25 and 16, which is going to be 41. So we'll have to square root that, and we'll get a decimal. So the square root of 41, if I round it, comes out to be about 6.4. So that would be plus minus 6.4. All right, now my center is no longer 0, 0 because they've added those numbers in up here on the top. So we've got y plus 2 and x minus 3. Now when we're talking about the center, the x always comes first. So this is written kind of backwards in that they have the x term second. So you just want to be careful of that and make sure that you pull the x term first. Because remember, all coordinates go x, y. So when it says x minus 3, we're actually going to pull out a positive 3 for the x coordinate. And for the y, it says y plus 2. So you want to pull the opposite sign, so it's actually a negative 2. So the center for this one is 3, negative 2. Now because 25... above that, so coming back up here, 25 is the bigger number, and above that is the x, I'm going to be using this side of my chart, the left-hand side. Okay, so I'm going to use all of this information to help me now find my vertices, my covertices, and my foci. And then we'll do the slope and those asymptotes like we did yesterday. All right, so using the left-hand side there, let's start by finding our vertices. So our vertices are when we do the h of our center, which would be the x-coordinate, so the 3. And we're doing plus or minus our a value, so plus or minus the 5. and then you have your k from the vertice, or from the center, which is -2. So 3 plus 5 would be 8, -2, so there's 1 point. And then 3 minus 5 would be -2. So -2, -2 would be the other vertice. Now, co-vertices, we leave the h of our center alone, so we leave the 3 alone. And you take your k, so that would be the -2 for this problem, and you add and subtract your b term, which is the 4. So you'll have 3, and then -2 plus 4 would be +2. And the other one would be 3, -6, because -2 minus 4 is going to be more negative. Okay, then for our focus points, we take our h of the center, which is 3, and we add and subtract that c value, so add and subtract 6.4. And then it's our k value of the center, which is -2. So instead of having like a bunch of zeros like we did yesterday, because it was all centered at the origin, this is changing. Okay, so 3 plus 6.4 would be 9.4, -2. And then 3 minus 6.4 would be -3.4, -2. The last thing that I would want to find is that slope, just so I kind of have an idea of where my asymptotes are going to be. Now we can still use, like we did yesterday, that box that we drew in and then draw those diagonals in, but this is just going to state what the asymptote should really be. So you're still going to do the square root of the number underneath the y on top, so that would be 16, over the square root of the number underneath the x term, which is the 25. So this comes out to be plus or minus 4/5. So those are your asymptotes. Now, like I said yesterday, you could actually use that to graph those dotted lines if you want to. But if you liked that rectangle box method that I showed you, you can still use that for these problems too. Okay, so I'm going to start by graphing my center. So that changed from 0, 0 to 3, -2. So my vertices, I have one at 8, -2. And then -2, -2. Okay, and again, if it's helpful to be labeling all these things, I'm going to go ahead and just put those letters next to them. Co-vertices, we have one at 3, 2. And the other one is at 3, -6. Then I'm going to go ahead and draw that box in. Then I'm going to draw in those asymptotes. So this is when you want to maybe use a straight edge so you can go from corner to corner on your box. And you're going through the center. Now, since we were on the left-hand side of the chart, again, that's when your major axis is the horizontal. So these are going to be the ones that open up to the left and open up to the right. So you go off of the vertice point and you kind of draw those two branches in. Okay, like that. And then my focus points are going to go a little bit beyond the vertices. So I have one at 9.4, almost 9.5. -2, and then -3.4, -2. So this is the focus point, And then over here is another one. Okay, so I want you guys to take a look at number 2 and go ahead and try this one.
Mark, to Mr. Barr's room, please. So this one is here, A is underneath the Y, and this side of the chart. So you're going to leave the H of your center alone, and you're going to do K of the center plus or minus K. So your center is this one. So you're going to do the -2 and 1, and then you're going to do -4 plus or minus your base value. And then like over is the H of the center minus your B. So your H is at -2, so you're going to do -2 plus or minus 5, and then the -4.
Okay, so I'm using the right-hand side of my chart to like fill all of this information out. Last I'm going to add here is my slope for those two asymptotes. So the number underneath the y is the 36, and the number underneath the x is the 25. So this is going to come out to be plus or minus 6 over 5 for that. So now I'm going to graph all of this. So there's my center. There's your vertices. Co-vertices, we have one at 3, -4, and -7, -4. All right, so I'm going to go ahead and draw in that box so that I can then draw in those asymptotes. Okay, and so these ones, remember all of those branches go off of your vertice point. So this is going to open up and down. And then I'm just going to graph those last couple points in, those foci points. So we're going to go just a little bit beyond the vertices. So there's one. And there's the other one. All right, the last problem on the next page, we're not going to graph this one. We're just going to create the equation using that completing the square method. So I just want to write out the equation for the hyperbola. I don't need to go and then find like the vertice and all that stuff to graph it. So we're just going to do some more practice with that completing the square because we've seen that show up with circles, ellipses, and now hyperbolas. So remember, the first thing that I told you guys to do on these kind of problems is rewrite it so that your x terms are together and your y terms are together. So we're going to put the 4x squared and the 32x together. And if you want to go ahead and draw in the first blank, you can, because that's going to be the first part of the completing the square. Now my y terms, we have negative y squared and a 6y. I'm going to go ahead and do my second blank. And then remember with whole numbers, so that 39, this one here, we're going to move that over to the other side. So we want to subtract it from the 0. So it says -39. And then we're going to add in 2 more of those blanks. Now before we complete the square, so before you do half of your b term and start filling in, for this portion and for the y, I'm going to take something out. So I'm going to factor something out first. So for the first one, I'm going to factor out that 4 because I like it to just be x squared. I don't like there to be a number in front. So I just want to try to get rid of that if I can. So I'm going to pull out the 4. So I'm going to be left with x squared plus 32 divided by that 4, if I factor it out, is 8. So plus 8x, and then our blank again. Now, with the y squared term, I don't really have like a number like 4 to take out, but I do have a negative that I want to get rid of, because again, I like it to just be x squared or just y squared. I don't want there to be a negative. I like my letters to be positive. So I'm going to pull out just the -1. So it's going to switch that to a positive y squared. And then it's going to say minus 6y now because I'm changing all the signs here. And then still plus a blank. I don't have to change the sign of that last one because Regardless if that middle number is positive or negative, I'm going to take half of it and then I'm going to square it. If you take a positive times a positive or a negative times a negative, you're always going to get a positive answer. So then over here, I've got that negative 39. And since I factored out some numbers, I need to add those in next to my blanks. So I took out a 4 from the first one, and I took out a negative 1 from the second one. So I just need to make sure that I keep that on the other side too. Whatever I took out of the left side, I got to do the same thing to the right side so that it still stays balanced. All right, so now let's complete our squares. So for this first one, we do the 8x, so we do half of 8, which is 4, and then we square that. So 4 squared is 16. So that's going to go in that first set of blanks. What am I doing half of on the second one? Good, the negative 6, which is going to be negative 3. Then we're going to square that. What's negative 3 times negative 3? 9. So 9 goes in for those ones. Now we rewrite. So on this first one, we still have that 4 sitting out front. And then remember I said kind of like your shortcut is you always use the number that you guys found when you did the half of that middle term. That tells you like what you put in the parentheses. So it would be x plus 4 squared. So how would we write the second one? Y and then what number? Good, minus 3 squared. All right, now over here, negative 39 plus 4 times 16. So that would be 64. And then we've got plus negative 1 times 9. So if I do the math over here on the right side, I simplify that, I end up getting 16. So now similar with the ellipses, when we had these completing the squares, we like them to say equals 1. So I need to get rid of this 16 and I need there to be a 1 instead. So what I'm going to do is divide everything by 16. So for this first one, 4 can go into 16 4 times. So this simplifies, so it says x plus 4 squared over 4. The second one, it's just going to have a minus sign here, and it's going to say y minus 3 squared over 16. I just dropped the 1 from in front. And then equals 1, because 16 divided by 16 is 1.